Okay, today we're going to talk about correlation and regression. This is chapter 10 in your book. So the first example we're going to use to make a scatter plot both by hand and on the TI-84 calculator. So the scenario that we're looking at says, are the number of homeworks completed correlated to the final grade in the course? All right, so we're going to go ahead and plot these points on the graph that you see to the right. So for our first point, we have homeworks completed, it's 10, and a final grade in the course of 42. So I'm going to place a point on the graph, approximately where that would be located. I'm going to continue to do that for every point on this chart. Okay, I went ahead and plotted those points on the scatter plot. We can see that there's definitely an uphill trend there, so it does seem to be a positive correlation. The more homeworks you complete, the higher the final grade in the class tends to be. Okay, we're going to do that same thing on the graphing calculator. So we're going to press Stat, and enter on Edit. And we're going to go ahead and enter these numbers into the graphing calculator, putting X values in list 1. For this example, the X values are the homeworks completed. Those are going in for list 1, and the final grade or the Y values in for list 2. Okay, I went ahead and entered again those homeworks completed in list 1 and the final grades in list 2. Then we press second, Y equals. I want to turn plot number 1 on. So let's go ahead and hit enter on plot 1. Highlight on instead of off. You need to pick the type of graph. The scatter plot is the very first one that we see, so we're going to keep that one highlighted. The default in the graphing calculator, the X list does come up as list 1 and the Y list comes up as list 2. If those do get changed for any reason, hit second 1 for list 1 and then under the Y list, second 2 for list 2. Okay, everything else, the mark and the color looks good, so I'm going to go ahead and hit graph. But notice that I'm just seeing the standard window from -10 to 10 on both X and Y axis. So I do need to zoom. So I'm going to hit the zoom key, and then zoom stat is the one that I want. That will zoom into the statistics, the numbers that I've placed into that stat edit screen. So zoom stat, it's number 9. Okay, and there we see the points, very similar to what we plotted by hand. Again, we see that there is definitely a positive trend, positive correlation to these points. Now, in statistics, we do need to be able to quantify how strong that relationship is. So we get into what is called the correlation coefficient. The correlation coefficient measures how strong a relationship between two variables. So if the relationship is strong and in the positive direction, the R value, the correlation coefficient, will be close to +1. So +1 means that there is a strong positive relationship between the two variables. That is going to be similar to what we're going to see with our example. If there is a negative relationship, and again, the points are all very close to a straight line, then the correlation coefficient will be -1. So this is going to mean a strong negative correlation. Now, 0 would be right in the center of this number line, and that would actually mean that there is no correlation between the two variables. So that's just going to look like a scatter of points. No uphill trend, no downhill trend, just a big scatter of points on your scatter plot. Most of the time, we are going to get values that are in between 0 and 1. and 0 and -1. So we're going to have to say, well, maybe it's not a strong positive, but a moderate positive relationship, or maybe a weak positive relationship. So depending on how close or how far you are away from this +1, you're going to have to come up with a descriptor word to quantify just how close to +1 you are. So typically we say weak, moderate, and then strong. Same thing on the negative side. So if we are closer to 0, that would be a weak negative. In the middle would be a moderate negative. And then towards that -1 would be a strong negative relationship. We are going to be finding those correlation coefficients on the calculator. So using the data that we have already stored from that last example, we're going to go to Stat, over to Tests, and we're looking for the one that says Lin Reg T-Test. It is towards the bottom, so I actually hit the up arrow key to get there quicker. So Lin Reg T-Test, it's letter F in my calculator. I'm going to go ahead and hit enter there. List 1, that is where I entered the X values, and list 2 are the Y values. We're going to keep that frequency equal to 1. And I'm going to highlight the not equal to case. That is typically the case that we look at for linear regressions. All right, I'm going to go down to calculate and click enter. One of the values that the output of this screen will tell us towards the bottom is R, and R is the correlation coefficient. So our R value for our example was 0.992. If I mark that on the number line, I am very, very close to that +1. So this is a strong positive linear relationship. Okay, we do have some examples here of other types and strengths of correlation. That first picture that we see is very similar to the example that we looked at. The points are all very close to a positive correlation line. So that would be a strong positive correlation. Now, if there's more scatter between the points, so there's still an uphill trend, there's still a positive trend to the data, but the points aren't as close to the line, then we would call that a weak positive correlation. All right, here we have a negative correlation between the points. So a negative correlation is as one increases, the other decreases. So a downhill trend. And this would be another strong relationship because the points are all close to the line. So a strong negative correlation. Here's an example of a weak negative correlation. Notice that there's more scatter between the points. Again, there's still a downhill trend, but the points are not as close to the line. So that would be an example of a weak negative correlation. Here the points are not as spread out as this one, but there's still some spread between the points and the line. So we might call this one a moderate negative correlation. And then here's our example of no correlation. This would give us an R value very close to 0. There's no correlation between these points, meaning there's no uphill trend or downhill trend. There's just a scatter of points there. So we would say no correlation. Okay, guys, here's the one that I would like you guys to take a look at. So it is describing a relationship between the number of absences and the final grade in the class. I would like you to draw out a scatter plot for this particular data, putting absences on the x-axis and grade on the y-axis. Go ahead and also graph the calculator, graph the scatter plot on the calculator as well to practice those calculator steps. And then find the correlation coefficient, the R equals value, and tell me if you think that it's strong positive, strong negative, weak positive, weak negative, moderate positive, or moderate negative. All right, guys, pause the video, see if you can do that, and then repause or restart the video to get that solution. Okay, hopefully you had enough time to take a look at that example. We have number of absences versus grade. So I plotted those points. We can see that there is a negative trend. So the more you're absent, it seems like the lower the grade is. I calculated the correlation coefficient over here on the Lin-Reg t-test. My R value is equal to negative 0.884. Be careful, those negative signs are very easy to miss, so make sure you're watching out for those negative signs. So this, I would still say, is a strong negative correlation between number of absences and grade. So we're still pretty close to -1. If you said moderate negative correlation, that's fine too, but it is pretty close to -1. In the Scatterplot, guys, I did enter the data into stat edit. Okay, and then since we hit second y equals and we turned our plot on and we selected the correct type of graph last time, we should just be able to hit graph. And then again, if we're not seeing all the points, zoom 9 to zoom in on the statistics that we have entered. Okay, that's what we're learning about today, making scatter plots both by hand and on the graphing calculator, finding correlation coefficients on the graphing calculator and interpreting them. In order to interpret, we need a strength and a direction. Okay, so strong, moderate, or weak, and directions would be positive or negative. All right, guys, that's it for today.